Hi, let's go ahead and discuss about the model evaluation metrics. The very first metrics is accuracy. Accuracy is one metric for evaluating classification models. Informally, accuracy is the fraction of predictions our model got right. And you can see here the formula of our accuracy. Let's say if you have 100 samples, in out of that 100 sample you have got a 95 correct prediction, then the accuracy is going to be here a 95%. For a binary classification, accuracy can also be calculated in terms of a positive and negative as follows. So this is the true positive, the true negative divided by here true positive plus true negative, and this is a false positive and the false negative. Alright, so this the true positive means if something is right, an algorithm predicted right, and this is true negative means if something is wrong, algorithm predicted wrong. And alright, so there we have a false positive here. A false positive means something is negative in a true nature, but our algorithm predicted it as a positive, that is a false positive. And false negative means something is actually a positive in a true nature, but algorithm predicted as a negative. The another metrics of model evaluation is precision. Precision is something like what proportion of a positive identification was actually correct. So the precision is defined as this formula: a true positive divided by here a true positive plus a false positive. Alright, so it is going to say that what proportion of positive identification was actually correct. Let's say you have 100 sample. In 100 sample you have there, let's say 90 sample was actually a true positive and 5 sample was negative in true nature, but algorithm predicted as a positive, so that becomes here a false positive. So in that case you have a true positive is here a 90. Alright, but overall the positive cases which algorithm predicted, it was a 95. So in that case you can say that here we are getting the precision, that is 90 divided by 95, which will be somewhere around the 95. Alright, so then here we have another accuracy, another model evaluation metrics is recall. So recall is kind of what proportion of actual positive was identified correctly. But if you see here the the difference, it says that what proportion of a positive identification was actually correct, and now it is saying that what proportion of actual positive was identified correctly. Alright, so it's saying that let's say we have total there 100 positive cases. In that 100 positive cases we are going to identify that what proportion of that positive cases in the actual is truly identified as a positive. So it's gonna be here a true positive divided by true positive plus a false negative, because a false negative was ultimately in nature was a true positive. Alright, so actually ultimately in nature that was a positive, but algorithm predicted that as a negative, that is why it becomes here a false negative. Don't worry about that. At the first time it was really very confusing to me as well, these false positive and the true negative and all those things. Don't worry about that. With some experience while following this course you will get the habit, and then finally you will be able to make the differences between all these accuracy, recall and precision. So here we have the confusion matrix. In the confusion matrix, we can say here is that a false positive. Sorry, one more thing I forgot to tell you about that. So these are the three actually true actual model evaluation metrics: accuracy, precision, and recall. Then we have here F1 score as well. So F1 score in general, you can say that that is the geometric mean of recall and the precision. All right, perfect. Now let's go ahead, try to understand what is the confusion matrix. A confusion matrix is a performance measurement techniques for machine learning classifications. It is kind of the table which helps us to know the performance of our classification model, and we can get here the true negative, false positive, false negative, and the true positive things from here. All right, let's say you have these classes of false, true, and false and true. Let's say this one is the predicted one, and this one is going to be, let's say, the true one. All right, so what is going to be here? If it is a false and it is a false, then it's the true negative, and if it is the true, so it is going to be here a false positive. So in the sense, what I'm trying to actually let me make it, just a second, let me get it here, pen first, then I'll tell you. Let's say you have it something like this, and this one is like this. All right, so this one I'm saying here, this is actually a true value, and this one is a predicted one. All right, don't worry about that. So this, my handwriting on this computer is not good. Anyway, so this one is the predicted one, and then we have here this true one. All right, so in this, what happened? The true nature of this false and predicted is false, so it's a true negative, and the true nature is false, but algorithm predicted is true, that is why it becomes here a false positive. And the true nature of the data point is true, but algorithm predicted here a false, that's mean this is a false negative, that's mean it is wrong, it predicted as a false. And then the true nature and the predicted value was a true, that is why it becomes here a true positive. All right, perfect. So this is all about in this lesson. Thanks a lot for watching it. I'll see you next lesson.